Hi, good afternoon, everyone. Hi, Sushant. Hi, Mahesh. How are you doing today?
Hi, Varun.
Good, good. So,
Hello.
yeah, hi, Sushant. So we're here today to talk about cultivating tomorrow. A little bit about the digital evolution in agriculture. So, before we jump into it, I'd like to just do a brief introduction of myself and my speakers. So, I have about over a decade of experience in product development and in startups. Worked in the IoT space primarily. Worked across industries such as smart buildings, pest control, and most recently for the last, let's say, about 6 years within the agriculture technology space. Um, Dr. Mahesh has a PhD in crop physiology from UAS Bangalore. He has a professional expertise in various areas of agriculture, including plant physiology and agronomy practices, um, and has served in key in several key roles in both academic and private institutions. And Sushant is an IoT enthusiast with about 6 years of experience within designing various components for IoT products. Has built IoT products for various industries, but over the last also about 6 years, has been focusing on the agriculture space. So welcome, guys. Hope you're ready for an engaging discussion.
Yep.
Great.
Yes, sure. Yeah.
So basically, I want to start with talking about some of the challenges that farmers and the agriculture industry as a whole currently faces. This, I mean, can become a very broad discussion, but just to set the context for the audience and for the people that aren't familiar with the agriculture sector as a whole, why don't we introduce some of the problems? So I'd like to direct this to Mahesh first, who's going to be talking about it from a farmer perspective, what happens on the farm. So Mahesh, from being an agronomist working directly with farmers, what do you see firsthand as some of the big problems that farmers face?
Thank you, Varun, for your kind introduction. Right. Yes, we are aware that Indian agriculture is very diverse and then very vast. So henceforth, you can keep on listing the many challenges faced by the farmers. But however, I look into a different perspective. Like say, I want to very specific problems the farmers face by. Mm, I put it in two different categories. One is knowledge driven, another one is non-knowledge driven. Knowledge driven problems such as your crop varieties, which are the crop varieties is suitable for your system in the field. Then how much to irrigate? That's the main drawback in Indian agriculture. As of now, Niti Aayog says 65 million hectares of total sown area is still under traditional irrigation system. Only 5% of the total sown area is under the micro irrigation, wherein you can precisely irrigate the crops. Then third point here is the package of practices. How best the practices can be done to produce the good quality harvests, and then the mitigation of pest and diseases. These are the, like say, the few knowledge-driven problems which are faced by the problems. Non-knowledge driven problems such as your farm activities, farm management, labor management, like say instruments, facilities. Other than this, like say the market driven production, so and so forth. These are the main points I would like to say that which are all uh, in general the farmers faced by the challenge, faced by the problem farmers. I
Yes.
think Sushant can give some insights on these problems also.
Yeah, so before we jump to Sushant, I just wanted to summarize. So basically, you've talked about the fact that the usage of water is currently a very big problem. We see that
Yes.
farmers are over irrigating their crops quite a lot, and because of climate change and more erratic weather patterns, water conservation and a more efficient use of water is becoming more of a priority for farmers these days. And then on top of that, you talked about access to agronomy r- related services, so such as what crop to sow, which variety to sow, as well as the nutrient and the pest and disease management. So we'll come to
Absolutely.
some of the potential solutions for that a little bit later. But I want to give Sushant the chance to talk about what sort of problems farmers face that are outside of the farm, so connected to the value chain as a whole.
First of all, thank you, Mahesh and Varun, to give us a good introduction about the program we are looking at. And thanks, Varun, for the nice introduction for us. So, Sushant here. As said, like as Mahesh had already pointed out, all the relevant issues on farm, what we a farmer face on a day-to-day basis. Apart from that, off-farm issues we can categorize under many categories. So I'll just summarize the point which we're looking at. So very first thing is having access to the credit. So you want to work, a farmer wants to work with a crop in which he wants to sow across. So he should have a capital, or he should be able to access a credit from a local market or a government body to source that seed and relevant parties like your pesticides, your fertilizer, other things, so that he can create a chain of processes in which he will be using those inputs for his field and cultivation processes. Apart from that, once these things are ready for him to manage, he has to make sure this item is also linked with the market. So today I'm having a requirement of a fertilizer which is a fertilizer A, and then tomorrow I have a requirement of pesticide B due to some local circumstances. Does my market allow me to have that in time and have the availability to process this? So these are the issues we will be facing apart from the on-field issues. And then once these two challenges are overcome, we have a third issue coming up is supply chain architecture, where once we have the crop ready to harvest, so is my supply chain ready to take it up, store it, process it, and then move it forward for further applications? So we have seen like sometimes the quality of a crop is not up to the mark what you see in the market. And if a simple store keeps us food for 2 or 3 days, the quality reduces. So does so this storage and the market infrastructure allows us to have a good control. So this is very much a difficult. First of all, it's a difficult task, not a simple task. So supply chain infrastructure is very much important. Many processes are already done in this case, like where these things are optimized as well as per market requirement. These are the issues we face for perishable, non-perishable, and long duration crops and all. And last will be the availability to the inputs. Uh, the produce which we make. So what are inputs are required while cultivating the crop, apart from the agronomy support and all. So earlier, if you say like technologies way back old in 1980, 1990s, we used to have like All India Radio where they used to broadcast some messages. And today technology upgraded, and then we have some new scenarios like WhatsApp groups or a channel or a simple KVK program where they gather a people of group of farmers and distribute information. So how these informations are distributed? So, the inputs here are not only related to the crop as required in a pesticide or a fertilizer, as well as the information at the right time and the right process in that area needs to be addressed. So how we will be challenging it? This becomes a challenging part to address, and the bottom line of this is needs to be a cost effective. So the last point will be the cost which we have to look for it, where it needs to be in a pocket friendly scenario to address to all the audience across.
Okay, that's great. Yeah, I mean, I think you've covered holistically the off-farm challenges which are affecting our farmers. Again, just for a quick summary there, you started off by talking about access to credit, then on the market linkages and the supply chain, uh, and finally the access to the inputs. Now, across the board, we've seen a lot of startup activities, specifically within this space, where it's looking at eliminating the middlemen between the farmer and the consumer, and even e-commerce for your farming inputs, such as seeds and fertilizers, as well as a lot of NBFCs that have now come up and focused within the agriculture sector, providing access to credit to farmers. Now, that's great, and but I think between the three of us, we have a lot of experience of what happens on farm, right? More than what happens off the farm in the value chain. So I want to direct our conversation towards that. So when we talk about the on-farm challenges, Mahesh, to you, what are the three like if you had to choose three of the biggest challenges to farmers, what would they be?
Uh, yeah, the first point would be the crop selection, crop information and selection, which variety should be selected, and then which variety or the crop is suitable for the farm. The second point would be the soil health, how best the soil health is to produce my crop. The third point would be the agronomy of practices, mitigation of pest and diseases. So just little bit give a little bit information on these 3 points. Crop information and selection would be like say suppose if you want to grow for vegetables. So which vegetables is suitable for my farm? Whether the farm is suitable to give the enough irrigation or not, and all. And then the whether the soil, if you come to the soil, like say the soil is having enough nutrients, whether it is having a good pH, EC, so that it can deliver the nutrients available to the crop throughout the crop cycle. And then the third point would be like say the agronomy of like say how best practices, like the how plant density can be maintained. Then the pest and diseases, like say suppose if you have a cloudy weather, which are the diseases or pests would be arrived, and then you can predict and then mitigate it as and when. So these are the best 3 points I can choose.
So I had asked you for three, and I think
There
those
are
are
many, right?
yeah, there are many more. I think I'd like to also just highlight for the audience that labor availability seems to be an extremely big challenge. Even in
Yes.
my personal family farm, we constantly have rotation of labor
Agree.
and trying to find
Yeah.
people that are reliable, who can stay, and who can work the way that we need them to work.
Yeah.
So yeah, so I would like to throw in the
Just to add into this, your labor, availability and management, wherein the like say, IoT technology can be intervened there to reduce the labor dependency in farm activities.
yeah, that's true. That's true. There is a lot of automation
Yeah.
and digital technologies that are coming in to help address that problem, which actually transitions me to the next point that I wanted to talk about, which are actually some of the solutions that exist today for farmers. So,
Right.
so just for the sake of keeping it diverse, I'll ask the next question to Sushant. So when it comes to market access, so giving farmers access to markets for them to sell their produce, what do you see happening today across India with regard to solutions to make it easier for farmers?
So this is a question like once you have the produce ready, what to do with the produce once it's ready. So usually common practice as on today is like they will connect with a local trader. Local trader can be your one of your what we say bulk buyers in an area where we can sell this product to, or a government body like APMC, where this APMC is also access now. So this is a new thing coming up. APMCs where uh, technology can add on to these and give them a real time price. What will be the price of purchase from the produce, and ability to share this price across that area. So if there are like 50 farmers in an area where they want to sell this item at, so it cannot be like a first person is selling at a price X and second person sells at price Y. So once we have this option to set a price for a crop for that time and duration, so all the farmer in that area will benefit the same element. So having the ability to share the price for the day and should be deliverable to all the community farmers available in that area. And then we have contract farming coming up, so where a private body or a government body working for a private body order scenario where they take up a common prescribed practices to be followed on your crop, and then track it over the time for the production of the crop once it is produced. And then we do grading, like once these practices are followed, we grade the product out of the quality produced done, and then this goes forward for this but post process of this food, in which it we add traceability to make the product valuable. And then you might have heard of new entities like ONDCs, ENAMs, where they help us to give a platform to sell my produce anywhere on a larger platform. So, ruling out any middleman in the picture, so that we have a common ground and a common price for all. So these are technological help we are getting as on today to address the issues of a farmer once we have many middlemen and other local bodies to rule over.
Yeah, so basically, what you're saying is for the farmers that currently do work within the traditional system of local traders and APMCs, having access to real time price information is important for them, which there are tools for already. And the the government of India does have a portal where farmers can access the real-time pricing for mandis all across India. And then, secondly, you talked about contract farming, which is basically eliminating the middleman, right? Where you have a crop grown for a specific use or for a specific buyer, which is something that a lot of startups are working on, as well as a lot of big agri institutions. But that may not always be available to farmers, right? These contract farming opportunities are few and far in between when you look at the large scale of agriculture in India. So finally, you talked about digital markets like ONDC and ENAM. So again, in the case of farmers not having access to a company that wants to buy from them directly, they can find direct buyers online through portals like ONDC and ENAM. So I think, yeah, I mean, there's a lot of work happening right now, both from the public and the private sector in addressing this market linkage problem. So going back to one of the things that Mahesh had brought up with regard to crop selection. So this is a big question that every farmer asks in the beginning of the season. What crop do I sow so that I'm most profitable at the end of the season? So, so Mahesh, can you talk about how the farmer goes about making that decision currently and how it can be improved?
Yes. This is the need of our question, Varun. Why? Because almost all the farmers think to produce more and then get benefited out of it. So first and foremost thing farmer should do that. So before selection of the crop, he should test for the nutrient analysis of his farm soil. Okay, he should have the information of his soil nutrient status, pH, EC, so and so, etc. What is the soil type, so and so that based on that he can select the crop. Okay, selection of the crop again it depends on the weather condition, whether the monsoon is onset or delayed or it will be very erratic and so and so. There are many varieties suitable for the like a late onset of monsoon or early onset of monsoon. So based on that he can select the varieties. There are short duration varieties, long duration varieties. Okay, based on that he can select based on the crop nutrient availability, the soil nutrient availability also. um, Apart from that, so he can look for the accessibility of the market where he can select. Suddenly he cannot grow the dragon fruit to sell it in some place. He can also should look for the crop market, that also. If you give a little more insight in then how best nutrient management can be done based on your soil nutrient status. Say suppose if you have a medium range of nitrogen or phosphorus potash is there in your soil, you can go for a little higher application of nutrient application so that you can produce good harvest. um, Apart from that, as I already told you that again the pest and disease management wherein it comes there, where the IoT technology can be intervened that to forecast and then how best we mitigate the pest and diseases. These
Absolutely.
are the best points I feel to say.
Yeah, so I mean, just a personal experience from my side. Before I got into agriculture technology, I actually rented about a half acre of greenhouse space close to
Oh,
Bangalore and started to grow exotic vegetables. And the first piece of advice that was given to me was find your market first, because especially when you're dealing with perishable goods. I mean, your harvest comes and you literally have a few days to harvest before they start over ripening on the plant, and you're kind of scrambling for a market. And then at the end, you're either giving it away for free to your friends and family, or you're getting a very low low price for it. So yes, definitely finding the right market for your crop, I think, is the first question that needs to be answered. And then subsequently, based on what market access you have or what crops have good market access in your region, then you go for the environmental suitability, whether it's suitable for your specific soil and the climatic conditions for that season. Really, I think a nice analogy is that sowing a crop in the beginning of the season is like buying a stock, where in the share market, where there's so many factors that are out of your control that affect how much profit or loss you're going to make after a certain amount of time. And really, the idea is to minimize your risk. I mean, and if you go through the right steps of making sure you choose a crop with, let's say, a stable price and one that is suitable for your field, then your chance of being profitable at the end of the season is higher. But that being said, there are a lot of things that are out of a farmer's control, but there are things that are in the farmer's hands, such as your nutrient management, your irrigation management, and your crop care with regard to the pests and diseases that you may face. So, so again, to you, Mahesh, what sort of you've talked about the fact that IoT and let's say for to extend that precision farming or smart farming can help lower the risk for farmers in their crop cultivation. So can you tell me a little bit about your experiences using precision farming systems to grow crops?
Absolutely, Varun. Yep. You have given a very good analogy on, like say, selection of the crop, how the farmer can invest in his crops. Good. Thank you, Varun. Uh, as our experience, in the sense our own hands-on experience on IoT, automation, irrigation, fertigation, so we have a farm, and then wherein we have installed this automation irrigation system there. This is how- this is it's based on the sensor based irrigation, so that you can irrigate the crops as and when required, real time irrigation. That the advantage here is you reduce the dependency. Second thing is you are not wasting the water. So we could observe that, like say, more than 30 to 30 to 50% of the irrigation water we saved. Then, so the balancing with the irrigation water, you can reduce the nutrient application to the crops also. So wherein we saw almost 50, more than 50% of the fertilizer application we reduced it. Why? Because we are irrigated only to the rhizosphere, wherein you say this roots are grown in the soil. We call it as a rhizosphere, where the roots are there available. So we are irrigated only to the rhizosphere, and then we applied to the fertilizer, applied to the crop with the nutrients as it required. Because of a very precise irrigation, we could reduce the runoff, we could reduce the nutrient wastage, and then because of your low irrigation, you could manage the less relative humidity. So the microclimatic region of the plant is well aerated, so that you can reduce the weed infestation or weed growth, pest attack. Pest in the sense both insects and disease attack was very low. Apart from that, you are maintaining the aeration in the soil, so the soil roots, plant roots also required aeration. That roots also respires. It requires air to respire to grow the roots. So you are maintaining the aerobic condition, not anaerobic condition. If you are irrigating, over irrigating it, you are creating the anaerobic condition wherein crop root growth hinders. So uh, these are the main points we observed by adopting the IoT automation irrigation system in our farm. This is a need of the hour. This information should be spread across the farming community, where should be educated to the farmers. What I
Yeah,
observed.
absolutely. Yeah, I think it's basically the next step forward. Like when it comes to how farmers deliver water to their crops,
Mhm.
going pretty far back, farmers used to, and actually still do for a lot of areas, flood their fields, right? So they actually turn on either a pump or they have access to a water source like a river close by, and they literally flood their fields. Then the introduction of drip irrigation came, which significantly reduced the amount of water that farmers use, because again, they're not flooding their field; they're delivering the water through these drip pipes exactly at the root zone of the crop. So, and now let's say soil moisture sensor based irrigation takes that even further. And if I heard you correctly, compared to just traditional drip irrigation and a standard package of practice, um,
Yes.
you've seen up to 50% savings in water for a crop, right?
Yeah, in our crop, we have grown the tomato and the capsicum. right now. Okay, so we have observed 30 to 50%. It's because based on the crops water requirement. In tomato, we have observed around 39% reduction in irrigation water than traditional irrigation.
Okay.
As I mentioned in earlier, like say the 65 million hectares of total sown area of in India is still under the traditional irrigation system. That is
Flood.
basin irrigation system.
Yeah. Wow. Okay, yeah. So you've talked about how precise irrigation helps with the growth of the crop. You did talk slightly about how that reduces the amount of fertilizer. Can you explain that a little bit more? It's not
Yeah,
obvious.
right. So, as we aware that soil is also having certain amount of nutrients, uh, were nitrogen, phosphorus, and potash. These are the main macro nutrients. Okay. So when we recommend in the sense any ICR institutes or state agriculture institutes based on the agroclimatic reason, they recommend the dose of fertilizer, like say how much fertilizer should be given to the crop. Like say for example, if you take tomato, because we have done extensive research on tomato, that's why I'm taking the tomato as itself. So Indian Institute of Horticulture Research, this is the one of the governing entity of ICR, under the ICR Institute. They recommend 100 kgs of nitrogen, 100 kgs of phosphorus, 80 kgs of potash is required for Karnataka agroclimatic region, wherein this has been developed based on the traditional irrigation system. So the as the common farmer, how he does the irrigation, based on that they have developed this dose of fertilizer recommendation. Now we call it as RDF, recommended dose of fertilizer. However, what we observed from our research in I know using IoT enabled automation irrigation plus fertigation unit there. So based on the soil moisture sensor based irrigation, so as I told you, we have given only the rhizospheric irrigation water we have given to the plant, so that what used to happen in the farmer field, we just think about that. Imagine that, like say if you're over irrigating and then more apart from that, in addition you are giving nitrogen or any kind of fertilizer, so the over irrigation will take away your nutrients from your rhizosphere of the plant. So thereby you are wasting the nutrients from over irrigation. uh, in our studies what we did, okay, we are over irrigation is not required for the crop, so that we can reduce the fertilizer nutrients load also.
So
It worked
basically,
well.
you're talking about a balance of water and fertilizer, where if
Absolutely.
you are using sensors to reduce the amount of water going into your field, then you need to reduce the amount of fertilizer going into the field. Do you have any
Yes.
experiences of trying to use the same recommended dose of fertilizer, but using soil moisture sensors to do the irrigation? And what was the impact on, let's say, yield and quality?
Ha. Yeah, we have done extensive work in tomato, capsicum, and banana. I'm just giving an example of tomato, but if you see in banana, we have reduced say 50% of fertilizer application for, in banana, and then 50% of the less irrigation as traditionally the farmers does. So the Bish ratio has increased that, right, in both the all the crops. What we have observed, the balancing of the both irrigation and the nutrient application works well. So thereby you can reduce the cost incurred for the fertilizer application as well as the water irrigation water. So nowadays we are facing a lot of irrigation water. We do many of the, like say agriculture lands doesn't have the irrigation water, so that we can use the saved water for the irrigation.
Absolutely.
Hmm?
Great. So before moving to Sushant on the sensors and the actual technology behind it, I just wanted to spend maybe another 2 minutes. You had talked about pest and disease management being another challenge, and you have talked about how precision farming systems or smart farming systems can help with irrigation and nutrient management. But how can they help with pest and disease management?
Absolutely. Like say agronomic practices, as we say, we say agronomically. As an agronomist, I say suggest farmers to go, like say, use plant the samplings in a distance, so that there will be aeration, should not be you know confined to microclimatic condition wherein you build up relative humidity, reduce the temperature, so that it is congenial for the disease or pest to come and then attack your plant, so and so forth. That is apart from your agronomy. As a technology oriented, like say you require to predict your disease or pest to uh, when it arrive in your farm. um, just to give an best example here is the grape farmers, where the farmers grow the grape. So they understood, now they are very well educated in predicting the disease called powdery mildew and then downy mildew. So they understood, like say, continuous 3 hours of rains comes continuously, and then there is a buildup of relative humidity in the your farm of above 95%, and then some window of 20 to 25 degrees Celsius temperature is there whole day. Definitely they will go for the next day spray to prevent the powdery mildew attack on the vineyard. So thereby he can reduce the like say more than 90% of the your pesticide application in the farm. Suppose you think that after the infestation of the powdery mildew he can go and then spray, means he has a chance of 50 to reduce the pest attack there. So thereby, uh, weather-based pest and disease management is crucial.
So basically, what you're saying is that the the IoT systems don't actually look for the pests, even though,
Yep.
but based on the weather conditions that are suitable for that pest or disease to multiply within the field,
Yeah.
that data is used to proactively treat the pests and diseases. And actually, from my experience, I mean, um, during tomato crop season, a traditional recommendation would be to spray once every 3 days, right? At the
Yeah.
certain stage where that pest or disease would affect the crop. Whereas using weather information and specifically microclimate weather information that is there within that farm, you don't need to spray every 3 days, and you just wait for the conditions to be suitable for that pest or disease to show up and proactively spray before the pest and disease start to spread, right?
Yep.
Okay, great.
Absolutely right.
Yeah, and you've seen that that's worked, and in your experience you have reduced the amount of sprays that you do, right?
Perfect. Perfect. You are right. Yes.
So Mahesh, thank you so much for that in-depth and I think very easy to understand agronomy lesson for all of us. So I want to go to Sushant for a little bit to talk about some of the sensors that are used in farming today, and what are some of the challenges with, let's say, implementing those sensors, and building a system that basically collects all of the data and then finally gives actionable insights to a farmer.
Okay. Yes. So as mentioned, like Mahesh sir has already covered across extensive points of what are the challenges we face and what are the things will be happening in the field. So as I said, to when we get to know there is a disease coming up, if we apply after it has occurred, so we have a chance of 50-50 to fix it up. Having a solution already, IoT solution already to identify your microclimatic weather of your field or any other parameter which is used to map how your crop will move forward, what will happen to your crop, will eventually help you to take an action in real time and solve it in the early stage where the availability of, or like we have a chance to kill this pest and disease faster from 50-50 to 70 to 90% as well. And we have seen these examples in our field, experiment field as well, where the microclimatic weather was used as one of the key factors and till it's been used across, so that we are able to take actions and we have prevented the growth of weeds in the field. So coming to the point of, so to the point of where what plant needs to be needs for a technology point of view, what we need to check for a plant to grow. So we start from very basic form. We start from the soil. What soil will be contributing to a plant's growth? Soil will contribute water and other microbial activities, and as well as we have laid down our pipelines for drip irrigation or a sprinkler or a bubbler scenario, many pipeline scenarios are there. So these will be used to distribute the required fertilizers and once we and the temperature. So there is a range of operation of a plant. In this temperature range it will work out, or how much water needs to be given in a shrubs scenario, in a medium growth scenario, and when it starts to give flowers, and then when its the fruit is being up. So each stage is now monitored in this case. So we say like a crop of capsicum will take 6 to 8 weeks to grow. In first 3 weeks it will take a little amount of water, or like the water requirement will be less because it's in the shrub size, and we need not to irrigate the field as we do in a general basis way. So to check this, we check for how much water content is in the soil. So we term it as soil moisture or water level in the soil. Next is the how much water is being evaporated from the soil, because soil being an open field, there will be a chance of evaporation. This term is now having a direct relation with the temperature of the soil it is being fed to, as well as the air around it, what is the temperature and humidity is available in that area. So
So,
these two
Sushant,
parameters.
I just want to stop you there. You had mentioned soil moisture sensors, right?
Yes.
And I think today, especially, there are many types of soil moisture sensors in the market.
Yes.
So, can you give our audience a little bit of clarity on what the different types of sensors are and what your recommendation would be?
Okay, so this in the context of soil moisture sensor, this is one of the key sensors which we see, like it helps us to manage across majority of the work we do in the field, when to irrigate, when to put fertilizer, when to put pesticides, and what to do with the further actions of the plants. So we have many types of soil moisture sensors. So basically, majorly they are categorized under resistive type sensors, a capacitive type sensor, and a combination of capacitance and resistance. So these are like time diffraction sensor scenarios. So the commonly used are one the resistive based sensor, where we have two elements in which we check the conduction across and see what's the conduction is happening, and then we arrive at the conclusion of this is the amount of water is in the field. The issue with this sensor is limited to if we have applied uh, fertilizers fertigation system in that area, or we have distributed fertilizer in that area, this reading will not be in accurate format up to 40 to 50%. Then we go for volumetric analysis, where we see what will be the mimicking, or we mimic the ratio of water which will be taken by a root of a plant versus actual sensor. In this case, we sample the output to an average value over a period of time of like 10 to 15 minutes, and then we take a decision, this is the right value of it. Here we'll be able to get the results up to the range of 2 to 5%. But obviously this range comes with a cost, which we have to see like how does it fit in the criteria. Lastly will be the time domain refractometry, where we see how much time it takes from two elements to conduct the electricity from point A to point B. So once we see in electronics format operations like electrical design format, the time duration it takes is equivalent to the amount of salinity a soil will provide me when water is poured into. So these are the ways, and these are giving me a range in the error range. These are like 15 to 35%. So the error factor is what is contributing to the complexity of the sensor and the price factor. Now, if
So
you
you're
are
saying more accurate sensors are more expensive, which is, I mean,
yes, yes, yes.
a pretty well understood concept. Okay, yeah. So go on. So you've talked about different types of soil moisture sensors. So when it comes to nutrient management, what sort of sensors are, let's say, I wouldn't say available. I would say what sort of sensors are commercially viable for agriculture in India today?
So we have many parameters to look for in a soil and the fertilizer we apply across. But as Mahesh has already covered across earlier, we are keen in knowing the soil nutrient, that is your NPK and pH and EC content of a soil, because these are the five factors which contributes the growth of the plant in a very fast manner. So any change in these values will have a direct effect on your plant over next 1 week. So we are looking at a short term change in these parameters. So we, as Mahesh said in the earlier, like once we start sowing a crop, we check for a soil nutrient level, what is the soil nutrient level is left with, and we apply accordingly the relevant fertilizer at start, so that this is maintained throughout the project. But there are some locally what we say forecasted issues, like you have heavy rain, suddenly you have a heavy rain, or suddenly you have a drought. Even though you have a viable water source, these will result in change of nutrient wash off, or your nutrient will be so dried up it will go below the root zone itself. To maintain this, we have sensors for EC, that's your electric conductivity, or commonly known as TDS. What is the salinity content of your soil? This helps us to maintain how much NPK saturation is available in your soil. Next is your pH, where the pH is an important factor for the soil to maintain the root life cycle. Any upper change or lower change, by looking at a +2 change, plus and minus 2 change here, will kill the root itself, in which the plant will die. So maintaining pH is very much crucial in this case as well. And then we have nutrient
Uh,
actually.
just to add in before you jump ahead, basically the fertilizers that are used are actually chemicals that we're putting into the soil, and we're putting chemicals into a biological system, and we need to make sure that the quantity of these chemicals that we put in doesn't hurt the crop. So, in a broad context, pH and EC are two very cost effective sensors, which are good indicators of an overall level of chemicals in the soil. But have you seen any sensors that will give me, for example, a real time reading of how much available nitrogen is there, phosphorus or potassium, your NPK? Because I've been looking for those for a while and haven't come across them.
Okay, so that's a good question. So there are approaches, like there are two approaches. Either first one is the deductive approach. As I said, like the salinity of the soil will have a direct relation with the concentration of NPK. And second is the actual test, is the refractometry test across, where we take a soil sample and then we run it through a spectrometer by making it a solution. And lastly, these are accurate up to 5 to 10%. Lastly, a lab test where the whole setup goes as a lab. So like as Mahesh said in this, like in the start of the crop may, we use a lab setup to get to know what is the NPK level. So these are the three processes in which the currently the NPK is used for a commercial purpose on a large basis. So once we have more insights, we like derivative solutions are less accurate, but we'll have an insight to look for to start with.
That makes sense. So going into the environmental sensors,
Yeah.
what are the main sensors that are important for agriculture?
Okay. So again, coming back to the field, if you have open field and if you have a greenhouse, so each of them is having its own requirement. So the common throughout will be the relative humidity in an area. So I'll just list out the parameters which we're looking at, and then I'll bring in the sensors which will be attaching to it. So parameter we start from soil, we start from air. So air may we have wind speed, wind direction, and rainfall. Wind speed will tell you uh, what will happen to your crop if it is too windy, or what will happen to the fruit of the crop if it is too windy. Wind direction will tell which direction it is flowing across, so that you can manage your uh, fruits falling from a tree and accordingly take an action across. Rainfall is one of the key factor where if you are having automation system, like we do experiment with the automation system to save water, we actually use this as a irrigation input for us. So if we have scheduled the irrigation tomorrow and we forecast there will be rain tomorrow, we can just skip the irrigation and save water for ourselves for other purposes. So that's a rainfall sensor here. Next parameter will be your radiation sensor, also known as solar radiation sensor or luxometer, where we see how much solar the sunlight is available for a plant to do photosynthesis, as well as it contributes to water evaporation apart from what we have irrigated. Then we have air temperature, air humidity, and air pressure. Sudden change in air pressure, meaning there will be a chance of high humidity scenario, and sudden change in humidity also represents a chance of having a disease being forecasted. So today there is a change. The propagation of pest disease will happen after day or two, but we have a notice to us saying that this has happened. There is a chance. Let's take an action so that we are 100% sure that disease does not come to us. And then to be with the plant, we have the leaf wetness sensor where we check how much water is being absorbed by the leaf in the scenarios. So these are the sensors I summarize across. We have plenty more. These are the commercially used or like widely used sensor to predict the pest disease model, as well as the crop availability and the crop the flower rate of sustainability with the wind scenarios.
Yeah, Mahesh, from an agronomy perspective, can you talk about how weather information can help with understanding the crop growth in the context of degree days, and also how evapotranspiration can be used to schedule irrigation?
Yeah, Varun, sure. Before adding to the points there, Sushant has given a very good information on all weather parameters. Um, for instance, if you take the weather, wind direction, wind velocity, and all, this information is needed for a farmer to when to go for the spray, how much to spray, and all. Because if you have, we recommend it if it is a more than 2 kilometers per hour wind speed is there, then we will not recommend him for spray any chemicals or pesticides and all. Likewise, so as you asked to look into the evapotranspiration, and then the irrigation can be done based on that. Um, if the no the to calculate the evapotranspiration, we require wind velocity, wind direction, temperature, and then relative humidity. These are required to calculate the vapor pressure deficit in the air, and then vapor pressure deficit in the leaf, so that the difference between the leaf and the air can be easily calculated. And then you can say that okay, this much of water has transpired from the plant, or like say transpiration and evaporation. Say evaporation is the water is going out from the soil to the environment is the evaporation in a simpler way, and then the water is going out from the plant to the environment is the transpiration. So that we can calculate based on the weather parameters, which as he has mentioned already, the relative humidity, temperature, so and so. And then coming to the like say prediction of your pest and diseases can be done with this weather parameters. If it is a high humidity, low temperature, and then so and so, you can there are many models in each crop to predict the pest and diseases. Then the
Uh,
phenology of the crop,
I'll actually
like,
just stop you there because we're running
right.
out of time and I kind of want to cover two more important topics. So I think it's pretty clear from the discussion that we've had and both of your experiences that precision farming actually has a lot of benefits for farmers and smart farming technologies and IoT enabled sensors and combined with an automation system does have a lot of benefits. So the biggest questions are why aren't farmers adopting it at a large scale? Um, Sushant, why don't you take this one, give this a shot.
Yeah. So very first thing I'll say, like the as we have already discussed earlier, like the ratio of the accurate sensor costs more. So cost is the very first criteria we are looking at. So for a farmer, the number says like almost 45% of the community falls under the below poverty line in India to even access these technologies. So we have to give a solution, but we should not give a solution which is like far more accurate than required, or like it's less accurate than the required scenario. We just can't give a wrong solution. So cost is a very big factor, which a farmer not able to do. And eventually, even if he wants to apply for the device, or the solution across, the financing agencies are reluctant to give, as there is a chance of risk of, will the financial agency getting this back money back from the farmer. He eventually, our device which we give across will work, but what the farmer does with the finance which he has received is the question mark. These are the two major, one of the two challenges. And then the education of the knowledge of precision farming and the automation solutions, and then the solutions for IoT enabled sensor. What are the artifacts which are useful for a farmer is not as abundantly available. The platform needs to be educated enough in languages. So we have we have the knowledge barrier, as Mahesh said earlier as well. So right knowledge should be given. What will happen after first year? What will happen after second year? What will be the advantages of this if being in a field? So these are the knowledge challenges, and then uh,
Yeah, I
the
think
community, adoption.
yeah, I think that covers the two biggest points. I mean, one is lack of awareness, and the second one being the cost. So, Mahesh, so to end this session, I'll actually turn it over to you. How do you feel like these two barriers of adoption, cost and let's say awareness, can be overcome?
Yeah, these 2 points are very pertinent now. Uh, in a single word, I should say that okay, we should bring the confidence in the farmer that okay, IoT things will work. We should bring the confidence in him that okay, these are work. As he mentioned, as Sushant mentioned, more than 45% of the Indian farming community falls in BPL, below poverty level. So we should look to reduce the cost incurred for the IoT things. Yep.
Got it. Yeah.
Yeah.
So definitely, as these technologies become more widely adopted, price will come down. But how do we get over the barrier of awareness and trust?
There are many institutes, SAUs are there, state agriculture universities Krushi Vijnana Kendras, Department of Agriculture, governed by state government of Karnataka. So there are many schemes they are implementing as and when required. Only thing is the upgraded technologies they are not included in their schemes. These things to be taken care by the institutes or KVKs or Department of Agriculture, so that this information can be spread over across the farming community and then build the confidence in them.
You say that that hasn't been done yet, but actually, from my experience right now, we are seeing that. I mean, we are seeing research institutes and state governments start to explore the idea of precision farming and smart farming, right?
Absolutely, absolutely. Right now, they are into the implementing in their institutes, but I feel lab to land is not happened in the sense still there in the lab, but not in the lab land. Okay. Uh,
Correct,
yeah,
correct.
yeah.
And finally, I mean, most, let's say, new agriculture products, when they're introduced into the market, whether it be a new seed variety or a new nutrient or a new pest or disease uh, treatment, trials are done, right? Where they do multi-location trials, get the local
Mhm.
community involved.
Yep.
So I also feel that that could also increase the adoption and build awareness and trust, where basically farmers like to believe what they see. So having it, done locally within their own fields or their friends' fields um, will will
Absolutely.
push this technology forward.
Yes, yes. Absolutely, you're right. The traction is happening, but not at like say 10%. Yeah.
Right. Great.
Yeah.
Okay, yeah. So I think that kind of wraps up our hour. Thank you so much, Mahesh and Sushant. I think this was a great discussion. A lot of good points. We started off talking about the problems that farmers face, focused on problems that are happening on farm. Talked about how digital technologies and smart farming technologies are helping farmers, and then finally concluded with some thoughts on how adoption and awareness can be increased. So I think this was a great discussion overall. Thank you so much for your time. And yeah, thanks.
Thank you, Varun. Thank you on all and all for this opportunity.
Thank you, Tim. Thank you for the opportunity.
Thanks.